Hi guys. So my topic was to draw all the products for an electrophilic addition to conjugated double bonds and to label the major and minor and kinetic and thermodynamic products. A molecule is considered conjugated when it has alternating single and double bonds, so pi and sigma bonds. When compounds are conjugated, they are more stable. So right here is an example of a conjugated molecule. As you can see, the double bonds are alternating from double, single, double, single, double. Forming an electrophilic addition to a conjugated molecule will give you two products, a 1,2 product and a 1,4 product. In this example, we're going to perform an electrophilic addition to 1,3-butadiene by adding hydrochloric acid. In the first step of this reaction, the double bond is going to act as a nucleophile and attack the hydrogen, which will bounce the electrons to the chlorine. This will form a carbocation intermediate, and the hydrogen will add to the first carbon. This carbocation can undergo resonance. So, the electrons from this pi bond will form a new pi bond, creating this molecule with a positive charge on the fourth carbon. Now, each of these molecules can react with the chlorine ion. Starting with the first carbocation, the electrons from the chlorine will add to the positively charged carbon, forming this product. This would be considered the 1,2 product because, as you can see, the hydrogen has added to the first carbon and the chlorine has added to the second carbon. We can also react the other carbocation with that same Cl negative ion. And the electrons will go to the positively charged carbon to form a similar product, but not the same. This product would be considered the 1,4 product because the hydrogen has added to the first carbon and the chlorine has added to the fourth carbon. In this reaction and under these conditions where there's no heat applied, the 1,2 product would be considered the major product and the 1,4 product would be considered the minor product. These products can also be classified as kinetic and thermodynamic products. When conducted in mild conditions, such as low energy or without heat added, the major product will be the kinetic product. However, if the reaction occurs in vigorous conditions, such as high temperatures, the major product will be the thermodynamic product. In this energy diagram, you can see that the first activation energy forms the first carbocation. This activation energy will be the same for either product. However, after the first carbocation intermediate, the 1,2 product will form without any further rearrangement, so it will have a lower activation energy. The second product, the 1,4 product, will have a higher activation energy, but it will form a more stable product. When determining which product will be the kinetic product, we look at the activation energy of each. In this case, the 1,2 product will have a lower activation energy, making it the kinetic product. To determine which product is the thermodynamic product, we decide which product is more stable. So in this case, the 1,4 product will be the thermodynamic product. Now we can do this reaction again, but this time with 1,3-cyclohexadiene and dibromine, and with the addition of heat. For the first step of this mechanism, we're going to bounce the arrow here and bring the electrons to a bromine, and then bounce those electrons to another bromine. This will form a carbocation intermediate with a bromine added to it. Like we did before, this structure can undergo resonance when you take the electrons from the pi bond and transfer them. This will form a carbocation with a positive charge on the fourth carbon. Then, just like we did in the previous example, we can react each carbocation with a bromine ion. The electrons from the bromine will add to the positive charge carbon in the ring, forming this product. This would be the 1,2 product. We can then react the other carbocation with the same bromine ion. And the electrons from the bromine will add to the positively charged carbon to form the 1,4 product, which will look like this. Now, using what we learned before, we can determine the kinetic and the thermodynamic products. The first product formed from the first original carbocation, which means it had a lower activation energy, making it the kinetic product. Now, when we have to determine the thermodynamic product, we look at the stability of each product. The second product, the 1,4 product, is more stable, so that makes it the thermodynamic product. Now we have to figure out which product is the major and which is the minor. When we look back at what we said before, we determine that the major product would be the thermodynamic product if heat was added. So in this case, the thermodynamic product, the 1,4 product, will be the major product, and the kinetic product will be the minor product. I hope this helped you guys, and if you have any questions or comments, please let me know.